Okay, thank you all for coming. I'm Judah Levine, and the faculty member of the department. Our speaker today is Professor Michael Dubson, who's over there. Mike got his undergraduate degree from University of Illinois in 1978, which is, you could do the arithmetic, it's 45 years ago. He was a graduate student at Cornell, and he graduated in 1984. He was then a faculty member at Michigan State, and he came here in 1995, and he's now the associate chair for undergraduate studies. Lucky him. Mike.
Thank you, everyone, for coming. Okay, great. Oh, and here's Jerry. Okay. So, I'm not a pilot. Is there anyone here who is a pilot? Private pilot? Oh, too bad, because if I had a question, I'd know who to ask. Okay, so I'm going to talk about the crash of a commercial jet airliner, a kind of scary topic, so let's begin with some safety statistics. What are the odds of dying in any single commercial jet flight? You know, when you step on a jet plane, it's a chance you won't make it. What are the chances? 1 in 14 million. Commercial airline traffic is remarkably safe, and it's getting safer all the time. And to put this in context, if you commuted to work by commercial jet so that you flew every day, one flight per day, it would take you 40,000 years before you were in a crash and died. So it's rare, really rare, that airplanes crash, commercial airplanes crash. You know, when a commercial airline crashes, it makes international news because it's so unusual. Now let's compare that to the odds of dying on the drive to the airport. Those are statistics that are easy to look up. In the US, there are 1.4 automobile fatalities per 100 million vehicle miles. So we drive a lot, but we don't get in fatal crashes very often. And if I multiply that by the 40-mile drive from Boulder to the Denver airport, I get about 1 in 1.8 million. And don't forget that wherever you fly to, you're going to be driving away from that airport, so you've got 2 chances to die in the car that day. And so your chances of dying in a car that day are 20 or 30 times higher than your chances of dying on the flight. So if you're afraid of flying, you should really be afraid of driving to the airport because that's the dangerous phase. So the next time you're in a plane and you hit some rough air and everyone gets real quiet, ooh, that's scary. Don't forget, if you're strapped in a seat in a commercial jet, you're safer than anywhere. You're safer than in bed at home. People die in bed all the time. Carbon monoxide poisoning, fire, home invasion, tornadoes. I think the only mode of travel that's safer than commercial airline travel is elevators. Certainly walking is much more dangerous than flying a plane. Pedestrians get hit and killed by cars all the time. Okay, now I'm going to talk about a particular crash. This crash happened at 5:37 a.m., July 26, 2002, more than 20 years ago. This was FedEx Flight 1478. It crashed on landing 0.7 miles short of the runway at Tallahassee Regional Airport in northern Florida. And the time was 1.3 hours before sunrise, so it was dark during the crash. Now, here's a picture taken of the scene the morning of the crash. So the wreckage is still smoking. You can see a scar on the ground where the plane skid to a halt. What happened was there was a stand of trees about a mile from the runway. The plane was trying to land here, and the plane was too low, and it clipped the tops of the trees and crashed. Now, there's a tiny little detail in this photograph, which is will be the subject of our story. There, you see these 4 little white lights to the left of the runway? That's called PAPI, Precision Approach. Yeah, let me just kill the board lights. That's the main thing. Yeah, hang on. There we go. Yeah, these 4 little white dots are part of our runway lighting system called PAPI. PAPI stands for Precision Approach Path Indicator. Okay, the plane that crashed was a Boeing 727. It was not a passenger plane. It was a FedEx plane carrying packages. And the plane is supposed to look like this. It's not supposed to look like this. and there was a crew of 3. All 3 survived. It was a pilot, co-pilot, and a flight engineer. They survived, but just barely. The plane caught fire the moment it skidded to a stop. And when the pilots attempted to exit the cockpit, when they opened the cockpit door, they were met with a wall of flame. So they closed the cockpit door, and they slid open this window on the side and jumped in the dark the 20 feet to the ground. And one of the 3 was very seriously injured in that fall, and the other 2 had to drag him away from the burning wreckage. Okay. Now, what were the conditions? It was dark. It was warm, and it was humid, but it was clear. Visibility was 8 miles. However, this airport is an out-of-the-way regional airport in the swamps of northern Florida. There were no large cities on the horizon as the pilots were coming into an approach. There were no lights anywhere. There weren't even street lights in the parking lot of the airport. What the pilots saw when they looked out of the cockpit was complete blackness. It's called a black hole approach. Black hole approach. You look out, all you see is black, except you see the runway illuminated by lights. And these 4 lights over here, that's the PAPI system. Okay. So, PAPI stands for Precision Approach Path Indicator. It's a lighting system, a visual lighting system, which gives the pilots an indicator of whether or not they're on the correct glide slope, the correct approach to the runway. The plane is supposed to approach the front of the runway at a 3-degree angle. This path is called the glide slope. And if they see 4 white lights, they know they're way too high. But if they see 3 whites and 1 red, they know they're a little high. If they see 2 whites and 2 reds, they know they're right in the sweet spot. They're right in the middle of the glide slope. They're coming down at the correct angle in the correct place. But if they see 3 reds, they're too low. And if they see 4 reds, they're very low. And very low is bad because that's where the ground is. And you can imagine how thoroughly pilots have it burned into their neural network that white is right and red is dead. Okay? I don't know about you, but I find it inconceivable that a pilot coming into a runway, an experienced pilot coming into a runway, would see 4 red lights and not notice that there was a problem. Okay, so let's look at this PAPI system. Here's 3 degrees to scale. So the plane, when it's doing the right thing, is coming in at a shallow angle. I've exaggerated it here a little bit. So if they're too low in this region, they see 4 reds. If they're up here, they see 4 whites. The region in space where they see 2 reds and 2 reds, 2 whites, is only 20 arc minutes wide. That's a third of a degree. So that PAPI system gives them a very clear indication that they're on the right path, a very narrow path that gets them right to the end of the runway. Okay. Somehow, the plane hit the ground nearly a mile short of the runway. Okay, so the NTSB, the National Transportation Safety Board, investigates all commercial airline crashes, and they determined that the crash was due to pilot errors. FedEx fired all 3 crew members. However, the crew members were members of a pilots union, and the union rules allow for appeal before a 3-person arbitration board. Now, the arbitration board isn't quite a court of law, but its rulings do carry the weight of law. Whatever the arbitration board decides, that's what's going to happen. The arbitration board could decide that the pilots were not at fault and reinstate them, and FedEx would just have to rehire them. Or the arbitration board could find that FedEx acted properly and the pilots just stay fired. So now it's a contest between the pilots and FedEx. Each side hires an expert to investigate the crash and possibly to testify before the arbitration board. This is where I came in. So the lawyers for the pilots union reached out to a friend of mine named Doug Duncan. Doug Duncan was for many years a faculty member in the astronomy department here, and at the time he was director of Fisk Planetarium. And Doug had a lot of experience giving expert testimony in court cases about visibility at night. He was an astronomer, so he could speak with authority about where the moon was and how bright it was and whether you could see. But Doug looked at this situation and decided this involves a little bit too much physics and optics for him. So he asked if I was interested in taking the case, because Doug knew I liked optics. And I said, well, what does it pay? Doug had already negotiated the salary, and Doug has a very simple policy for what his salary is in a court case. Doug's salary is whatever the hourly rate of the lawyer is. That's his hourly rate. Well, the lawyers were charging $150 an hour, and this was 20 years ago. So I said, okay, I'll take that job. The lawyers had already done some legwork for me. The lawyers had uncovered this alert from Transport Canada, which is the Canadian version of the American FAA, Federal Aviation Authority. The Canadian FAA had sent an alert to all Canadian airports saying that these PAPI units could produce false signals due to buildup of frost, ice, or dew. Now, you're not worried about frost or ice in July in Florida, but you are worried about dew. And so, because of this possible failure mode of the PAPI units, the Canadian people were told you've got to keep the PAPI unit on for at least 30 minutes before any landing, because that'll ensure that it's hot enough. The lights inside are very hot. That'll ensure the PAPI unit is hot enough that any ice, frost, or dew will burn off. Okay, so here's what the PAPI units look like up close on the side of the runway. There's 4 of them. And the lawyers immediately asked, do you want us to send you one of these? You know, they were going to ship. They had no problem just packaging up the whole thing and sending it to me. And I said, no, it looks heavy. In fact, it's 200 pounds. And it's about yay big, this wide. And I said, all I need is the manual. I just need to understand how it's going to work. Well, the manual was surprisingly unhelpful. Obviously, the manual was not written for a physicist, because there was no section in the beginning called theory of operation or how this thing works. It was obviously written for a technician. Hey, welcome. Come on down. We got a few handouts here. Just grab a colored card. Here, why don't you just pass those out to your friends. Thanks. So the manual for the PAPI unit was written for a technician who was just trying to get the PAPI unit to function. So the very first line was, check that it's plugged in and turned on. And then check the fuses. And, there was a series of a whole section on fuses. And then you had to check these voltages. And if this voltage read too low, you have to replace this board. It just went on and on about possible failure modes and what to do, never explaining what the PAPI does. At the very end, at the very back of the manual, was a single schematic showing the layout of the optical components. Now, when I saw this diagram, I knew how it worked. It's a slide projector. And there's just a light source, a slide, and a lens that projects an image of the slide onto the sky. You can think of the sky as just a distant, big screen. Now, I've given this talk many times, and often I give it to physics students. So I work in a little bit of optics. So the most important thing to know about a lens is characterized by a focal length, where if you have a bundle of parallel rays coming in, a converging lens will make the light rays converge to a point 1 focal length away from the lens. So when you buy a 50 millimeter lens at the camera store, that means the focal length is 50 millimeters. And I go on and on about how great optics is, but I'll spare you. I am going to ask you a question about optics, however. Are you ready? Now, this is what your colored cards are for. Okay, I'm going to ask you a multiple choice question, and you're going to vote A, B, C, or D by holding up the correct letter. Okay? The internationally recognized response for I don't know is this. Okay? Okay, so what I want you to do before you answer the question, I want you to turn to your neighbors and confer. It's called peer instruction. If you don't know, ask your neighbors if they know. Okay, so here's the question. A bundle of parallel light rays approaches the eye, and some of the rays enter the eye's pupil. No other rays enter the eye. What does the eye see? Or more precisely, what does the brain that's connected to the eye perceive? A single point of light surrounded by blackness, a uniformly illuminated wall of light, like a white wall, many scattered points of light, like stars in the night sky, or none of these, something else entirely. Don't vote yet. Confer with your neighbors. And then we'll have you vote in about half a minute. Okay, so get ready. Fold the card appropriately so that you have the correct letter showing, and get ready to raise your cards on the count of three. 1, 2, 3. Okay, I see B's, A's. It's B's and A's. A pretty even split. I see one C over there. Okay, B's and A's. All righty. So here's the thing. First of all, how would you make a parallel bundle of rays? Well, if you have a laser beam, that'll do it. But, you know, there's a much easier way to make a parallel bundle of rays. If I have a point source that's far away from me, the rays are heading out isotropically, uniformly in all directions. But in my direction, if the point source is very far away, the rays that reach me are nearly perfectly parallel if the source is very far away. So, for instance, a star in the sky is shining a parallel bundle of rays on me. And what an eye is a single converging lens in the front of your eye, and that makes these rays converge to a point on your retina. So what you perceive on the retina is one point of light, just as if you're looking at a star in the sky. So the answer is A. So you get 1 point if you voted A. Sorry, you get 2 points if you voted A. You get 1 point if you voted B. We always give participation points. Okay, so in a little more detail, here's the PAPI optical system. There's a light source with a reflecting mirror behind it to concentrate the rays on the slide. There's a couple of lenses which remove something called chromatic aberration. And then there's a front cover plate to just protect the innards from rain and squirrels and leaves and things. And here's what the PAPI, the Precision Approach Path Indicator, projects onto the sky. It projects this. And if you're approaching the runway in a plane and you're too low, you're staring at a red dot, a red light coming from the PAPI. But if you're too high, you're staring at a white dot. And as you go lower and lower, the white dot suddenly changes from white to red. Now, this is what would be in the sky if there was one PAPI lighting system. But remember, there were 4 of them. And the 4 are aimed up into the sky at slightly different angles. So for instance, here would be a 2 PAPI system. Okay? So if I'm way up here, I see 2 white lights. And if I'm way down here, I see 2 red lights. But if I'm right in the sweet spot, I'd be seeing one of the PAPIs looking white and the other one looking red. So the real PAPI system is 4 PAPIs, and the pilots are looking for 2 whites, 2 reds to be in the sweet spot. Okay, so now the question is, if the front cover plate fogged up, if it was covered with dew, would that affect the behavior of the system? And so instead of sending me the whole PAPI, I just had the lawyer send me the guts of the PAPI. All the parts were numbered, and I said, send me all these parts. So here they all were, and I just set them up on a rolling table, a little stand, and assembled it. It wasn't hard. Very simple electronics. Okay. So the lawyers didn't know any optics, and they kept asking me questions about, well, suppose just the top half of the lens fogged up. Wouldn't that make it do this or that? And I had to teach them a little bit about optics, and I'm going to ask you a question about optics. Okay? Suppose I have two point sources here, two spots of light, and I have a lens which is projecting an image of those 2 points of light onto a screen. Okay? The images are labeled 1 and 2. 1 on the left, 2 on the right. Okay? A mask is used to cover up the left half of the lens. What happens to the images on the screen when the mask covers the left half of the lens? A, image 1 vanishes. B, image 2 vanishes. Or C, something else happens. Don't vote yet. Confer with your neighbors. Okay? Okay, what do you think? On the count of 3. A, B, or C? 1, 2, 3. Oh, it's B's and C's and 1A. Iconoclast. Good for you. Okay. B's, man, the B's and C's are pretty evenly split. Well, let me show you what happens. Here's the mask off to the side, and here are all the rays of light from the point source on the right. The rays of light go every which way, but the rays of light that hit the lens get refracted, bent by the lens to form a focused point right there. So this point is the image of this star. And notice that the entire lens is participating in the production of that image. And if I put in the mask to cover up the left half, whoops, I still get a point source right there. And so what will happen is if I cover up the left half of the lens, both images will still be there, but just dimmer. And I had to explain to the lawyers, if half the lens was affected by dew, it would have almost no effect. You would still see, the PAPIs would still function. Basically, the whole lens had to be covered with dew before there was a problem. Okay. All right, one more question. And this has to do with dew, okay? A hot copper cube is initially at 40 degrees centigrade. Room temperature is about 20 degrees centigrade, so this is hot, okay? And it's suspended from a thread outside. The air temperature is a constant 20 degrees Celsius. The cube cools. Is it possible that the cube can cool to a final temperature lower than 20 degrees centigrade? Yes. No, because that would violate conservation of energy. No, because this would violate the second law of thermodynamics. No, because of some other reason. Okay, I want to put you at ease. Okay, when I ask this in a room filled with physics professors, I get about 20% correct. Okay? Okay, so maybe that's a clue that the obvious answer isn't the right answer. Anyway, confer with your neighbors, and I'll ask you to vote in just a few seconds. Okay, keeping in mind this is a hard question, I'll ask for the votes in 3, 2, 1. Okay. A's, D's, B's, boy, C's. I'm trying to see if there's a majority winner here. Well, it looks like A's are about not the majority, but more A's than others. And A is the correct answer. It can cool to a temperature lower than the air temperature. And the key word here is outside. So for instance, if this cube is outside on a clear night and the cube can see the sky, the cube can cool by radiation to a temperature lower than the temperature of the air temperature. So if you voted A, excellent. There are 3 mechanisms of heat transfer. Conduction is the thermal vibrations by direct touching of atoms. Convection is bulk motion of the hot object. And radiation is transfer of heat energy by electromagnetic radiation, namely light. So we're all radiating right now in the infrared. And when you go out under the night sky, your body is radiating upward into the night sky, but there's very little radiation coming back at you from the night sky. And so the night sky is cold, and you cool off. So now I got to tell you a little bit about the dew point, which I actually learned about in 4th grade. Okay, I have my 4th grade science book, and the dew point and the difference between relative humidity and absolute humidity, they were teaching to 9-year-olds back in the 60s. I don't know why. Anyway, what's the dew point? It's the temperature of the air at which water vapor precipitates and you get rain. The dew point depends on humidity. High humidity means there's a high dew point. 100% humidity means the dew point is equal to the temperature of the air. And anytime the temperature of a surface is lower than the temperature of the dew point, water is going to condense onto that surface. And as you probably aware, dewdrops are extremely fine. And in fact, dewdrops, the smallest dewdrops, are comparable to the wavelength of visible light. Consequently, dewdrops very strongly scatter light. Okay, if I have light going through a clear glass plate, no problem. But when I fog up the plate, you get a lot of scattering. And you're aware of that. You know, small droplets scatter much more strongly than large droplets because you can see through glass that has raindrops on it, but you can't see through fogged glass. And you can see through falling rain, but you can't see through clouds or fog. Clouds or fog are tiny droplets of air, of water vapor about a micron in diameter. And you can, well, anytime you've got the droplet size, the scatterer, the same size as the wavelength of light, you get very strong diffraction effects, very strong scattering. Okay, so I had to figure out how to fog up the front cover plate of my homemade Pappy, and it was easy to do. I just bought a steam cleaner. And when I waved this in front of anything, it just fogs up instantly. Okay, so I took my homemade Pappy and I put it in this room right here. I just rolled it right in here and pointed it at the screen. And I had a graduate student assistant, and I took a picture, okay? And then I just waved the steam cleaner in front of the front cover plate and then took another picture. Okay, so here we go. This is clear, and here comes fogged. You ready? Fogged. Clear, fogged. Clear, fogged. First thing you notice is that it's a lot dimmer. It's a lot dimmer because when it's clear, all the light is focused in a forward cone. Well, when it's fogged, now the light is scattered everywhere in a forward hemisphere. So the light is much more diffuse. Furthermore, I get a whitish pink and a pinkish white down here. We took 10 witnesses, subjects, selected at random because they were the first 10 people who walked by in the hallway. And we asked them to come down here and just move your head up and down. Move your head up and down and tell me when you go from white to red. And not one of them could tell where the transition was. They just said, I'm just seeing sort of a bright pink. Everywhere they looked, it looked the same. There was no sudden transition that they noticed. Okay, so the question is, if the pilots, instead of seeing bright white and bright red, they sort of saw a soft whitish pink or a soft pinkish white, how would they interpret that? Well, now we come to what for me was the most fascinating phase of this investigation, and that is human perception of color. So you might think that our brains detect color. Actually, no. What our brains detect is color differences. The human brain perceives color by comparing different colors in your visual field. Turns out this is a much more accurate way of determining color when you live in a world with vastly varying lighting conditions. You know, it might be high noon or it might be sunset, where everything is bathed in the red glow of the setting sun. But your color perception has to be about the same in the two conditions, because you got to notice that yellow tiger on the horizon, otherwise you're going to be removed from the gene pool. Okay, so now let me dim the room lights so that I'm going to remove your ability to compare to different colors by darkening the room. Okay, so how would you describe that square in the middle of that red square? Does it look white? Okay, now how would you describe that square in the middle of the white square? Does the little square look pink? Yeah. Okay, well this square, little square in the middle, and this little square in the middle are actually the same square. Okay, exactly the same square. This one looks pink when I compare it to white, but that same color looks white when I compare it to bright red. Your brain has a color comparator. Okay, now I have a much more dramatic example, and this one blows my mind every time. Okay, now a fair percentage, something like 8% of the population has some degree of color blindness. Do you see a green spiral and a blue spiral? I do. Raise your hand if you see a green spiral and a blue spiral. Okay, most people are raising their hand. Okay, now I'm gonna, so this one right here, I see that as a green spiral, and this one right here, I see that as a blue spiral. Aqua, okay? Let me zoom in on the upper left-hand corner there, and let me blow up that section. And now let me remove two little sections and put them together, okay? What you were claiming was green and blue are exactly the same color, sort of a greenish blue. Okay, at this point, a lot of people in the audience think I tricked you somehow. I changed the pictures. No, I didn't. No, I didn't. That green and that blue are the same color. Your brain refuses to accept that because your brain is doing some color comparison, and it gets confused depending on what colors I'm comparing to. Okay, so what's the point here? I think that if the pappies were abnormally dim and sort of whitish pink, when the pilots compared that to the bright red at the end of the runway and all the bright red lights in their own cockpit, I think they'd interpret that as white. Let me go back to a little brighter illumination here. Whoops, didn't mean to do that. Turn those on. Okay. Don't want anyone to fall asleep just yet. Okay, now, so if the pappy fogged up, yeah, it's going to give the pilots misleading signals. So, did the pappies fog up? Well, I have no way of knowing, but I do know that the conditions that night were ideal for fogging up. If the pappies ever fogged up, they would fog up on that night because it was 100% humidity. It was a clear night sky, so the objects, the pappy could cool by radiation. The time was just before dawn, so the pappy and the surroundings had maximum time to cool overnight. The pappies were turned on remotely by the pilots only 3 minutes before landing, and so the pappies were cold, and we did experiments and showed that the pappy front cover plate takes about 10 minutes to warm up and defog if it's been fogged up. Oh, and for me, the most important thing was the airport employees reported condensation on the windows when they came into work that morning. Okay. A very important point in the investigation was whether or not the condensation clears when the PAPIs are turned on. And the answer is yes, but slowly. We did experiments and showed that the temperature of the front cover plate rises about 1 degree Fahrenheit per minute after you turn it on. And you got to get the temperature of the surface of the glass higher than the temperature of the dew point before the dew will evaporate. And we did careful measurements with an IR thermometer to check the temperature of the cover plate. So the PAPIs were turned on by the crew 3 minutes before landing, but according to our experiments, it'll take 10 minutes for any dew to burn off. So here's the flight path. Here's the actual path in purple of the plane. This was reconstructed from the black box data from the plane. So here on the vertical axis is altitude in feet, and on the horizontal axis is position in nautical miles. And the zones of the PAPIs are indicated here. And the pilots just flew lower, 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 and they just went right down into the 4 red zone, and they were too low on approach to the runway. So the pilots made several, I've decided that the right word is missteps. Maybe errors, maybe gaffes. I like the word missteps, okay? The original flight plan of the pilots was to have an instrument landing, but they decided to change the flight plan and land on a visual landing runway. Runways are either instrument landing or visual landing. In an instrument landing, you're landing on a runway that has a radio beam that the plane is flying through, and there's an instrument in the cockpit that instantly tells the pilot too high, too low, too far to the right, too far to the left. Instrument landing. There's another runway, visual landing runway, where the only thing you've got is that PAPI, and you've got to look out the window and see. Well, there were 2 runways at Tallahassee Regional Airport. One was instrumented, one was visual flight rules. They chose the visual flight rules. They had the authority to do that, but they didn't have a good reason why they did it when they talked to the investigators. You'll see when we look at the reconstruction, they misidentified the runway initially, and so they had a late lineup and a sort of rushed checklist as they did their final approach. The pilots ignored danger signs. They were descending too fast, wrong descent rate. They were too low, wrong altitude. And, most important in my mind, there was intermittent obscuration of the runway by the tops of the trees as they got close. Okay, my conclusions? It's extremely likely, overwhelmingly likely in my opinion, that the PAPIs fogged up, causing the pilots to see 4 whites, meaning you're too high, safe, but too high. And the view of the 4 whites just masked other danger signs. We'll see when we look at the cockpit recording, the pilots sensed that something was wrong. But I think all the signals they were getting that was telling them something seems wrong, all those signals were just overridden by their view of 4 whites, making them think they're still too high. Okay, the pilots did make multiple missteps, but the PAPI fogging was the final link in the error chain that led to the crash. A crash is never due to one thing. It's due to a series of failures, and the PAPI fogging was the final link in the error chain. Okay, the NTSB got to completely different conclusions. The crash was due solely to pilot errors, and the PAPIs operated normally. Okay, what about the arbitration board? Arbitration board agreed with the NTSB the crash was due solely to pilot errors. What about my conclusions? Why did the arbitration board ignore my conclusions? It's because the arbitration board never heard my conclusions. Now we come to a clash of world's views. Clash of worldviews. There's physics world and then there's lawyer world. They're different. Okay. I was asked not to testify. The lawyers hired me. They actually owned all the data I had collected for them. And they told me, we're not going to call you to testify because your conclusions are going to contradict the pilot's previous testimony. The pilots had previously testified they saw 2 whites and 2 reds. And the lawyers were trying to build a case that these pilots were completely reliable, stand-up guys. They never make mistakes. And I was going to get on the stand and say, no, I think it's likely they saw 4 whites, and that explains why they kept drifting down. Well, in physics world, that's no problem, because in physics world, human memory is the least reliable form of evidence. You know, when I hear on the, you know, it's a physics thing. When I hear on the news that some court case, you know, the case is weak because all they've got is circumstantial evidence, I go, well, that's the best kind of evidence. If you've got eyewitness testimony, that could be completely wrong. But if you've got physical evidence, circumstantial evidence, oh, that's good. Okay, but lawyer world says, no, my client's testimony is the most reliable form of evidence, or at least I'm not going to put someone on the stand who contradicts it. So they never heard from me, and the pilots stayed fired. Okay, so what about the NTSB, who originally decided that the pilots were in error? Here's the NTSB investigation team, 34 people, okay? Now I gotta give you a little backstory here. When this case was all done and the pilots were fired and I was released from further duties, I went and read the NTSB crash report for the first time. The lawyer specifically instructed me, do not look at the NTSB investigation report, because if we put you on the stand, the first question is going to be, were you biased by reading the report? And I was going to be able to say under oath, no, I was not biased because I never read the report. But when I was released, I read the report with great interest. Okay, how'd they come to conclusions that were just opposite of mine? So here's 34 NTSB staff versus me. Okay, so why are you going to believe me versus them? Well, there was a lot of physics involved. Geometrical optics, me scattering is scattering of objects with size comparable to the wavelength of the electromagnetic radiation. Heat transfer mechanisms, meteorology, color vision. These are all physicsy things, okay? The report actually had the resumes of all 34 of these people. Not one had a physics degree. I'm sure they took physics courses to get their engineering degrees, but not one was a physicist. Okay, so here are the NTSB conclusions. Dew contamination enlarges and blurs red-white transition zone. That's kind of true. Transition zone appears as a broad pink signal. That's kind of true. Evaporates within minutes after a lamp's turned on. That's a bizarrely ambiguous statement. True. But 1 minute is different than 100 minutes. 3 minutes is different than 10 minutes. What do you mean by minutes? Okay, does not alter transition zone angles. And here's the one, cannot appear red signals to appear white or vice versa. So my conclusions, yeah, this is true, but only after 10 minutes. This last one, the key one, is wrong. It's just wrong. I showed it was wrong, okay? So with great interest, I read the report to see how did they come to this conclusion? How did they decide that the PAPIs cannot fail when the front cover plate gets covered in dew? Here's what they did. They made a phone call to the manufacturer. That was the extent of the NTSB's investigation of the effect of dew on the PAPIs. They called the manufacturer, a phone call. They didn't even go visit, just a phone call. They picked up the phone and said, if the PAPIs get fogged up, will they fail and cause the crash of a $30 million plane? You can imagine their response. You know, they said, no, our PAPIs don't fail. Okay, so here's the accident summary. The first officer was the flying pilot, and that's very common. The pilot and the co-pilot switch roles. They take turns landing so that they both get lots of experience. Okay, the key one here is PAPI lights indicated too low for 40 seconds before the crash. I think that's extremely unlikely. In fact, I find it impossible to believe that experienced pilots would see 4 red lights and just continue to descend. What they saw was a very dim, whitish pink 4 lights, and they just interpreted that as, I'm a little high, I'm just going to keep drifting down. Okay, so don't worry. You're never going to be on a plane that crashes because of PAPs. Yeah, question? Yeah, they're used in both daytime and nighttime. They're very bright. Very bright. You can see them in the day. Yeah. So, but this was at night. Yeah, they're used for both daytime and nighttime landings. They're especially important at nighttime landing because you have this black hole approach where you get no visual cues from the horizon and surrounding lights. Okay, so if you're worried about you crashing a plane because of the PAPIs failing, don't worry. Someone at the NTSB, sorry, the FAA, Federal Aviation Committee, Federal Aviation Authority, got the word because later on, all airports in the US got this CERT alert telling them that possibility of due may cause incorrect light signals after pilot activation. So to make sure this doesn't happen, the PAPIs are to be operated continuously. Don't ever turn them off so they never get cold. Keep them warm at all times so due cannot change. The word got back to the manufacturer in Germany. The manufacturer started building PAPIs that had no off switch. The moment you plug them in, they come on and they stay on. The only way now to turn off the PAPIs is to walk out onto the runway and yank out the power cord. PAPIs are going to stay on, don't worry. So, yeah, the power will be on as long as there's not a power failure. Airports have backup power. You know, airports know that, you know, they can't rely on the local Excel to keep the runway lights on. They've got backup generators. Okay, so bottom line, philosophy of science is that the final test of the validity of any idea is experiment. So NTSB is a pretty remarkable organization. They always get it right, except, at least in this case, they got it wrong because they just failed to do the experiment. I did the experiment, so you should believe me. Why didn't they do the experiment? I think they sort of lowballed this one because no one was killed. That really surprises me because even though no one was killed, there was a lot of grief over this airline crash, and I'll tell you why in a minute. But first, I'm going to show you something very instructive. I'm going to show you the black box reconstruction of the path of the plane in the minutes before the crash. Okay, so let me figure out how to get out of here. 1 second. Okay. So, first thing the NTSB does is get the black box, and then they fly it to their lab, and they open it up, and they carefully get all the data out, and then they use that data to reconstruct the exact path of the plane as it approached the crash. Okay, so I'm going to pause this. It's only about 2 minutes long. I'm going to pause it at several points to make commentary here. Okay, so again, I didn't see this when I was doing the investigation myself. Okay, FedEx flight 1478, landing accident. Okay, this is a reconstruction displaying data from the cockpit voice recorder. Okay, you're going to actually see, I'm going to pause it right here. You're going to actually see the conversation between the pilot and the second officer. The second officer was flying the plane. They released the transcript of the cockpit recording, but they never released the audio out of sensitivity to relatives of possibly dead pilots. You know, in a lot of crashes, people die, and they don't want the voices of their loved ones on the news. So they released the words, but not the audio recording. Was there a question back there? Yeah. Sorry? Oh yeah. Oh yeah. Yeah, they've got instruments all over the place. But it's called cognitive overload. You know, you got conflicting signals, and your brain has got to quickly decide, who do I believe? 4 whites, I think, is what they believed. Okay, you'll see, yes. Okay, so right now, they're actually heading off in the wrong direction. It's only a few minutes before landing. But they're seeing a distant red light on the horizon, which they interpreted as part of the runway. But it just turned out to be a red light on a radio tower. And the air part is actually off to their left. And they're going to notice that in just a minute. What's happening now is they're going through a checklist where the captain is reading off a checklist of things that have to be right before they land. And the second officer who's flying the plane is checking. Okay. Okay. Captain down in 3 green, check. Auto brakes, don't have those installed. So a little confusion in the cockpit. Apparently flaps 20 degrees, auto spoilers, question mark, not installed. Flight and nav instruments, cross-checked, no flags. Normal checklist, and then, okay, so at this point, this is what the pilots would see if they were looking at the runway and the PAPIs were operating normally. They're already too low. 3 red lights, 1 red light, okay? Okay. The first officer has just noticed that the runway's over there, and he's heading there. So he says, oh, sorry about that. Just as he says, sorry about that, a voice comes on in the cockpit. GPWS stands for Ground Proximity Warning System. It's a downward-looking radar, which notices when the ground is coming up too fast, and it calls out the altitude. It's a woman's voice, because the Navy determined some time ago that a woman's voice is much more likely to capture the attention of a male pilot. Okay? A woman's voice calls out in the cockpit 1,000, meaning they're 1,000 feet off the ground. They're too low, but they're talking over that, and they don't notice it. Pilot, first officer says, oh, sorry about that. I was lining up on that paper mill or something. They're seeing this distant red light. And the captain says, oh, that's all right, no problem, because they're both looking out the left side window, and they see the runway right there. So they do a hard left bank. And there's the runway. But if the PAPIs were operating normally, they'd see 3 reds and 1 white. But they continue to descend. Now there's a stand of trees about a mile in front of the runway. The checklist continues. The ground proximity warning system calls out 500. They're way too low, but it just doesn't register. And now something very telling happens. The first officer is sensing that something's wrong. First officer says, I'm going to have to stay a little bit higher or I'm going to lose the end of the runway. Okay, this is a remarkable statement because you never interrupt the checklist with small talk. The checklist has to be done right or you die. So you don't just like say something random. The person flying the plane is telling the captain, listen, I'm going to deviate from the flight path. I'm going to level out a little while because it just feels like I'm too damn low, or I'm going to lose the end of the runway. What the pilot is noticing, what the co-pilot is noticing, is that the trapezoid is becoming a little bit too much foreshortened. It's not, he can't quite verbalize what the hell is wrong, but he senses something's wrong. So he says, I'm changing what we're doing. I'm going to level out. And the captain says, yeah. Okay. Flaps, the checklist continues. 33 green light, clear to land runway. Okay, FedEx, 1478 short, final runway 9 near Tallahassee. The captain's just calling out, he's broadcasting to any planes in the area that we're about to land, stay out of our way. Okay. Now, as they get very close, they're very low. And what happens is the tops of the trees are starting to interfere with the view of the lights in the front of the runway. But remember, it's completely dark. They can't see the trees. All they see is that something is starting to obscure the green lights at the front of the runway. And the captain says, it's starting to disappear in there a little bit, isn't it? He's noticing that the runway lights are blinking on and off. That should have triggered an immediate abort. Anytime something's obscuring the lights, that means something's in the way. It might be birds, it might be ground fog. You don't know, you don't care, you don't take any chances. You just abort, you fly around and try again. But they decided, no, here's what happens. When they got a little closer, the tops of the trees just came down a little bit so that they could see the runway again. And the captain says, think it'll be all right, yeah. Okay. Oh, GPWS calls out one last time, 100. They're a mile and a half from the runway, but they're 100 feet off the ground, okay? And that just doesn't register because I think they're seeing 4 whites. Okay, the last bit of bad luck is that the trees directly in front of them are a little bit lower than the trees just to the right of them. And so there's a little bit of dip in the trees that allow them to see the runway. And they don't know that there's a tree off to the right that's a little bit high that's going to hit their wing. And boom, hits the wing. GPS, I love that the GPS warning system just keeps calling out 40, 30, 20, but now it's too late. They've crashed and continues to the end. Okay, so there's a wonderful, there's an amazing little epilogue here. So FedEx was extremely unhappy that this particular plane crashed because among the packages that burned up were disputed Florida ballots from the 2000 presidential election between Al Gore and George Bush. The ballots with the hanging chads, they were on that plane and they all burned up. Well, talk about grist for conspiracy theorists. So FedEx was just furious with those pilots, and so I sort of understand why FedEx wanted those guys out of there. Okay, that's the end of my story. Thanks for your attention. We have time for questions, and then we're meeting outside in the hallway for cookies and refreshments, and I'll be happy to talk to you out there. But any questions? Yeah. No, the pilots, the Pappies had a radio receiver listening for a signal from any airplane in the vicinity. So the pilots have a button in their cockpit that says Pappy on, and they push that button, and that activates the Pappies, even though it's miles away. And the procedure is to activate the Pappies 3 minutes, well, they activated it 3 minutes before landing, yeah, which wasn't enough, yeah.
Kind of adding on to that, whose responsibility was it? The pilot's responsibility to have that turned on in advance?
Oh, well, see, they did. It was the pilot's responsibility, and they did turn it on in plenty of time. See, there was nothing in their training to indicate that you have to turn it on early. All they have to do is turn it on at any time so they can see it. And so from their point of view, it didn't matter whether they turned it on 2 minutes before landing or 20 minutes before landing. All that was important is that they turn it on soon enough that they can see it during the landing. So they had no idea that they needed to turn it on 10 minutes early. So we can't blame them for that. Yeah, way in the back. Yeah.
Did they ever change the voice of the morning?
Yeah. Well, now that you have AI, I wonder if they emphasize, okay, it's clear you're not listening to me. You're too damn low. They should emphasize the warning. I don't know. Yeah, you don't think so? It still just says, pilots are bombarded with information. So it's people who design cockpit interiors have to be very careful. You don't want to flood the pilot with too much information because then you get cognitive overload and you can't tell what's important. Somehow the pilot has to be trained to key in on the important information and screen out the other stuff, even though they've got 50 gauges in front of them, 50 pieces of information. They've got to key in on 1 or 2, and that's a hard job. Yeah. You had a question? Yeah, the default is always instrument landing. And their flight plan was instrument landing. And they changed the flight plan, which they had the authority to do. And when asked, why did you change the flight plan? They didn't have a good answer. They said, well, we thought we had a little tailwind on the instrument landing, so we wanted the two runways were at right angles. So the visual flight rules landing didn't have a tailwind, but it was like a 4-knot tailwind, completely negligible. I think there were two things going on. I think there was a little bit of machismo there, you know. These are stick and rudder guys, and they said, I don't need no damn computer to tell me how to land this plane. I can see the runway. I'm going to put her down. And, well, again, it was a misjudgment, but it wasn't officially an error because they had the authority to go with the visual landing. But the standard is instrument landing always, yeah. Oh, yeah. Yeah, even if they were, oh, yeah, well, yeah, I don't know about I think if they had gone instrument landing, they would have realized much sooner that they were aimed in the wrong direction because if you're on instrument landing, you don't need to look out the window at all. There's a crosshair, there's a screen with a crosshair, and you got to get the crosshair on the ball, and it just tells you too high, too low, too far to the left, too far to the right, so you can just steer. So yeah, pilots can, you know, when instrument landing was first being developed in the late 1940s, they finally had the guts to do experiments where they would just put curtains over the cockpit windows and see if the pilot could land the plane safely, and sure enough, they could. So pilots aren't supposed to land in fog, but they can if they have to. They don't have to see anything out the window to land instrumented, yeah. Yeah, that's a good question. The pilots admitted that they were tired. They had been in that cockpit for 13 hours. They were eager to get to the motel so they could go to bed, and they admitted that. And so I think they were just feeling a little internal pressure. God dang, I don't want to fly around. That'll delay me another 20 minutes, and I'm tired. So I kind of feel for the pilots. They were fired, you know, their careers were over. They did make many misjudgments, but I am unhappy that the arbitration board didn't see the evidence that the PAPIs actually failed. And I'm also kind of surprised that they weren't suspicious about the PAPIs because I just find it inconceivable that any pilot would see 4 red lights and just ignore it. But that's what the that's what the arbitration board concluded. So the answer to your question is I have mixed feelings. I wouldn't want to get on a flight with those guys because they were allowing them, you know, they were flying tired and they got themselves into that situation. I don't know. Hey, yeah.
Picking up on your last statement.
Yeah.
They didn't see your evidence.
Yeah.
But something changed after.
Yes. Yes. Somehow the FAA got the word that the PAPIs were hinky. Okay. They didn't see my data, but I suspect somebody else figured this out. And it went all the way to the top, and the FAA said, and they immediately went to every airport in the U.S. And overnight, the PAPI procedure was changed. And within months, the manufacturer was delivering modified PAPIs that couldn't be turned off, so not subject to human error anymore. Yeah. No, I don't think so. The visibility was good. The visibility was 8 miles. So even though it was 100% humidity, there was no mist, fog in the air. If the temperature dropped a little bit lower, it would have started precipitating. But no, it was just fog on the front cover plate. Yeah. Oh yes, yes. All fields. Oh, that's why I wanted there to be a pilot in the room. I think all runways are either instrument flight rules or visual flight rules. I don't think you have a mix. Am I right or wrong? I don't know. Yeah. So I know the little. I can actually, if you go up to NCAR and you look at the runway down there, at what's that runway down there? Sorry. No, Boulder Municipal is north of us. There's a runway south and east of us toward Westminster. What? Sorry? Yeah, the Broomfield Airport. Yeah, that's private pilots land there all the time. And from NCAR, if you look down there, you can see the 4 red lights of the PAPI. And they're bright red because I'm on the ground, so I'm obviously too low. But yeah, I noticed they're on all the time. So yeah, all runways have PAPIs all runways have PAPIs or instruments. And I'm not sure if there are runways that are both. So I just don't know. Yeah. Yes. So we would turn the lights on, and the dew would just stay there, and we would monitor the temperature. And it was 10 minutes before the dew started coming off. Now, of course, whether it's 10 minutes or 9 minutes or 15 minutes or less is going to depend on a lot of things. What was the exact temperature? Was there any wind? How hot were, So all I know is it's quite likely that the PAPI's fogged. I can't say for certain that the PAPI's fogged. I think if we're in a court of law and you want to go with reasonable doubt, yeah, there's reasonable doubt in my mind that those PAPI's failed. I'm not sure I answered the question. Yeah, right. It might have been longer. I did not reproduce the exact conditions of the Florida swamp. The humidity in this room is Boulder humidity, 0 compared to 100% in southern Florida. Yeah, did I see another hand up over here? Sorry. Oh, yeah, sorry.
I was wondering, had you been allowed to take the stand and had your evidence been heard, how do you think that would have changed the outcome?
I think the arbitration board, first of all, the arbitration board, I think, would have said, okay, we admit the PAPI's failed. It's clear, because the evidence is just undeniable. But I kind of suspect they still would have fired the pilots, because the pilots made several misjudgments. Now, whether or not they deserve to be fired and what the arbitration board would have done, I don't know. But I'm sure the arbitration board, the arbitration board were independent people. They weren't airline people, they weren't FedEx people, they were just independent. And I think they would have looked at the evidence and decided, yeah, those PAPI's are failing. We better get that alert out to the airports, which the FAA was doing anyway, so, yeah. No, I didn't want to talk to the pilots. The lawyers actually told me, you can't do that. You were part of the investigation, so you can't talk to our clients. I did call the FAA, and I called the FAA on at least 3 occasions, and I would start to explain my story, and the person I was talking to would always say, oh, you need to talk to my supervisor. And they would pass me up the chain, and then I would get high enough where I would be talking to a secretary, and the secretary would say, he's not in today, he'll call you back. And they never called back.
Did you talk to them before the certs got changed or after the certs got changed?
Oh, I talked to them after the certs got changed, yeah. So, the problem was all, I think from their point of view, this problem's been identified and put to bed. We don't want to talk about it anymore. I think that was their bottom line, yeah. Yeah.
What do you make of the pilots saying they saw 2 white and 2 red lights?
Yeah, I'm not sure. I mean, the lights were abnormally dim. They expected to see 2 whites and 2 reds, but that doesn't, if they saw 2 whites and 2 reds, that doesn't explain why they continued to sink faster than they should have. The only thing that explains to me why they had this very fast descent rate was they always thought they were too high. So they were seeing 4 whites. Now, they were probably seeing a pinkish white, so it was sort of on the hairy edge, and it was dimmer than normal, and it was in their peripheral vision, and they were going through this checklist. There was a lot of things going on, so I can sort of see them getting a little confused. But the bottom line is, nobody's memory is very good after the most traumatic event in your life. I mean, do you really remember that the red light turned green on the way to work this morning? No. You remember that you arrived safely to work, so you infer that the light must have turned green before you went into the intersection. But suppose suppose when you ran into the intersection, you were T-boned, and you were in the hospital for weeks, as one of these guys was. And then they started talking to you about, tell me what happened in the seconds before the crash. Your memory's not going to be any good. So it's the physicist's attitude that, eyewitness accounts, worth listening to, but always taken with a grain of salt. Might be right, might be wrong. Yeah. Oh, it wasn't really a research project. So I often, in the courses I teach, I often teach optics. How do lenses work? How do cameras work? How do slide projectors work? And this is just a nice example of how, yeah. Yes? Well, no, no, it wasn't my students. It was just a grad student who I had handy. I needed people to, help me wheel stuff around and help me take the pictures. And yeah, it was just one guy. And he was just a underemployed TA. And I said, hey, have you got a few minutes to come help me? I need you in the picture for scale. So no, he wasn't really involved in the investigation. The pilots told me, the lawyers gave me very bizarre instructions. They said, don't talk to anyone about this. The only people you're going to talk to about your results are us, the lawyers. Keep minimal notes. Yeah, this one really bugged me. Keep minimal notes, because anything I wrote down is part of discovery and has to be shown to the other side. And that one really bugged me. And I kind of ignored them and kept notes. And I showed them the notes. And because, I gotta keep track of what I'm doing. And that's just the way science works. And they were like sort of, we told you not to keep notes. And I go, sorry. Yeah. So we are now 15 minutes over. So I'm going to thank you again. I'll be happy to talk to you more out in the hallway with cookies and refreshments. Thank you. Oh yeah. Just you can just leave them in your seats. We'll pick them up. Thanks. Yeah.
The experiment you showed on the screen.
Yeah.
Where it's all white or pink or something.
Uh-huh.
I would say they saw 2 whites and 2 reds.
That's what they said.
Let's assume that they remember something like that.
Uh-huh.
Can you go from your experiment to maybe redder on one side than the other, something like that?
Yeah. Anything.
Okay.
So